Uh, see if that works. So as usual, we're going to wait a minute for everybody to get in. All right. So probably be some more stragglers soon, but we'll go ahead and get started. So quick rehash of what we've been going over. So last time we started talking about compound interest, and so we found that if you don't just compound interest at the very end of the term, if you compound it continually, then you get this kind of additive effect where every time you compound it, the previous amount gets added to the principal. And when we applied this formula, it ended up looking something like this, where A is the total amount, P is the principal, R is the annual rate, And N is the number of times per year that it gets compounded. And then T is the time in years that the time in years, yeah, that the loan is out for. So last time we did this one, and when we did all the math out, we found that Dana had, where's my math? Dana had gotten the total amount at the end of the 3 years was 35, 90, 44. Again, just after applying this little formula and putting it in. So what we're going to look at now is, let's do the same problem, 4.5%, 4 years. On the one hand, we're going to do annually, and on the other one, we're going to do it semi-annually. This means, does anybody know what semi-annually means?
Half of it?
Half of what?
The annual?
Yeah, so it happens every half of a year, or twice a year. Usually, technically could mean multiple times, but if there's no other context, they generally just mean twice a year. So let's take our equation. Forgot to equals P1 plus R over N times T. All right. So given that, if we're doing it annually, what does our equation look like?
Mm-hmm. You about to pull up the time and stuff?
So
Okay, so
you need P, R, N, and T.
So P is 3,000.
Okay.
R is 4.5.
Okay.
And then 4 is N, right?
N is going to be one of the things we're looking for.
Okay.
What is N?
Is it 4?
For annually.
No, 12, right?
No. So
would it be 1?
It's 1, exactly. Oh. Yeah, I know it's weird. So don't you know, be real mad at yourself if it's not always completely obvious. One of the reasons these things are done this way is it's kind of confusing, and it allows them to mask some things. And that's not like the main reason. There is mathematical sense behind it, but the fact that it's weird is helpful for them. So yeah, N is 1. because it's how many times it happens per year. And so what is T?
4.
4. Yep. All right, so our equation then looks like this. 3,000 is P. Sorry, I still got some people coming in. And then we have 1 plus R, which is 0.045 or 4.5%. And divided by N, which is 1. And then N times T, which is 1 times 4. So when we plug all this in, we get 3,577 and 56 cents. Okay, fairly straightforward. Nothing too crazy. So,
I think I did wrong.
I'm sorry?
No, go ahead.
No, you're fine if you got a question.
I said I think I did something wrong. I'm gonna just redo it myself and see.
Okay.
You can go ahead.
All right, so if we do the same problem, but semi-annually, what changes?
N would change, right?
Well, on the first one, we did it annually. It gets compounded annually. On this number 2, we're going to do it semi-annually. What do we say semi-annually means?
Half of the year.
Yeah, so it happens every half a year, every 6 months. So, what changes?
N would change.
And changes.
So would it be 0.5?
Other way. So
Zero.
how many times a year does it happen? Well, if it happens every half a year, that means it'll happen 2 times for a whole year.
Oh, okay.
Yeah. So 0.045 for 2. 2 times 4. All right. So when you plug all this business in, you get 3,500. Nope. 84.49. Okay. So the way in which we compound it does actually make a difference. In this case, it's kind of a small percentage rate, and it's not that huge of a difference. But we do have, what is that? About 11. Oh no, it is 7. Oh, where's my math? 13. What's the difference? 7, yeah. So 77 to 84 is about a $7 difference. The only difference is we compounded it twice a year. So we can actually keep this going. Let's say if we compound it quarterly or daily. What happens, and I will show you the math on it. But if you compound it quarterly, what does N equal? If I said you were going to compound it quarterly, so quarterly.
4, wasn't it?
Yeah. 4. And what about daily?
Daily would be 365.
Yeah. Very good. So N is just how many times per year does it get calculated. So I'll let y'all see what those two would look like. Find my stuff. So in quarterly, N equals 4. And you get 3,588, which is, again, a little bit more than 84. And if you do it daily, 365, 3,591, which is an even smaller jump. But if we compound it over and over and over, it will always get bigger. So
Can you go back real quick?
yeah, so I'll be, these notes are all going to get posted online. So in the normal place where I put our notes. So if you want to copy them all down, welcome to, but not totally necessary. Copy down the big important stuff. All right.
Yeah.
Okay. All right. So let's look at the next one. Where's my control? So suppose you want to take a trip to Tahiti in 5 years, and you decide that you will need $5,000 to take that trip. How much money should you deposit? Hold on, got some stragglers. How much money should you deposit into a bank account paying 6% compounded quarter? This is the kind of real life problem, I guess, we're going to be asking ourselves.
So P would be 5,000.
Sorry, I'm writing my thing up again. Okay. So you think P would be 5,000?
Can you go back to the numbers?
So P is how much you start with. So if you're
Yeah,
taking a loan, it's how much you take out. And if you're saving, it's how much you put in. But 5,000 is how much you need at the end.
So that would be A.
Exactly. Yeah. So 5,000. Okay. What about any of these other numbers up here?
Well, R would be 0.06.
Yep. So
N would be 4.
0.06. All right.
N would be 4.
N would be 4. I think I agree.
Why would N be 4?
Because it's quarterly.
Okay.
So because it happens quarterly or every quarter of a year, that means that it happens 4 times every year. Yeah. I don't know where I was going on that. I just said it and that was it. So yeah,
Time
very
would be 5.
And time would be 5. So in this case, what we're actually looking for is
Solving for P.
P. Exactly.
Okay.
So let's go back.
So would you end up solving that and then subtracting that from 5,000?
So we're not subtracting it from 5,000. So what is assumed to be right here? If you just have a number outside the sheet, what do we assume you're doing to it? You had 5 and 3 like that. What does that equal? 15. So what do we assume we're doing right here?
Multiplying.
Multiplying, yeah. So in order to solve for P, we have to get this thing on the other side. So how do you get it on the other side?
Multiply, right? Something like that. Or divide.
Divide, exactly. So you're going to divide this thing underneath over here. So 5,000. And I'm going to simplify things a little bit. If you divide this by 4, you get 0.015. So that means this is 1.015 to the 4 times 5 is 1.015 to the 20. $5,000. I get 1.3466.
Fuck, I missed it.
I get 37.12.3. So this is yeah, this is what I get. So yeah, like with most word problems, it's usually, at least at our level, the numbers that you don't know, or the numbers that they give you, you can more or less plug in, and then just solve for the one that you don't know. So pretty straightforward. And I do give an equation sheet with these kinds of things on there. So don't worry about having to remember all that or anything. It's all about applying it for you guys. That's all I really care about. So inflation is this other thing that kind of goes along with all of this. And inflation here is a measure of your relative purchasing power. It's the cost of the same item after some period of time. The formula for inflation is usually just given like this, which is the same as the other formula we had, just where n equals 1. The idea is, you know, everybody listens to a grandparent say, well, back in my day, Coke was a nickel. Okay, but now Coke is not a nickel anymore. So the idea is that price has been inflated. But seen another way, that nickel is not worth a nickel anymore. So this is what helps us figure out what level of inflation we have. And so the way it's defined or set up is as an annual thing. Nobody really notices, I guess, when like prices across the board don't just go up by 10% one day. It's one store suddenly has a slightly higher price, and then another store, and then over time, everybody will eventually have that higher price, but not so much, it doesn't happen usually instantly, which is why we have to do it with this annual idea. So suppose that your income is $21,600 per year, and you will receive a cost of living raise each year. If inflation is steady at 4%, what is your income in 15 years? So note that this money, this amount of money will not mean that you can buy anything else, because everything else also went up in price. And that's the whole idea behind cost of living increases is in order to stay at the same level that you're at, your pay needs to go up. Because if it doesn't, then you're going to start getting poorer and poorer because the price of everything else will go up. So what, what do we have in what places?
I'm 15, right?
Yeah, I'm sharing it. Sorry, I forgot to share the screen on that one.
Tom is 15.
All right. So again, inflation is the measure of your relative purchasing power, and it's run by this equation, which is the same as the previous equation, but now we have n is just equal to 1. So this is the one that we're doing. So what is what?
R is 0.04.
So we have equals 1 plus 0.04. Okay, I think I agree. Now what?
Is P 21,600?
P is 21,600. Because that's the starting amount.
Then T will be 15.
And T is
15.
15. Exactly right. So when we do that and plug it all in, we get something that looks like this. All right. So I'm going to plug that in. So 1.04 to the 15th is 1.8. So 21,600 times 1.8. So in order to just stay at the same level, again, you can't buy any more, Snickers bars or whatever 15 years later. You need to be making almost twice as much. So in 15 years, $38,900 will buy the exact same amount of stuff as this. So when you get jobs that you're planning on being at for a while, this is something to make sure that your company is taken care of. If you're going to be there for a good bit, you need your actual pay raises from, just all the work you do, that kind of thing. Being better at your job, giving the company more. But that needs to be kind of separate from this cost of living increase stuff. Most companies don't do it every year. They might do it every 3 or 4 years. But
You round. I'm
sorry? I rounded?
Yeah, because my calculator, you did?
Yeah, so I got 38,940 cents.
I don't got that.
What did you get?
I think because I had just cut it off. I did 1.8 times the 21,600 and got 38,880.
So it is, if you actually do this, it's 1.80094.
Okay.
So yeah, I did round.
All right. Makes sense.
Yeah. But when I rounded when I wrote it,
Mm-hmm.
I didn't want to write all this extra junk. But
Okay.
I kept it in my calculator, which is usually a good idea, is to don't ever round it until you're actually like putting the answer in. Then you can do your rounds. If you round before that, yeah, you're going to get weird numbers. And that might, if you do it enough times, it might end up being wrong.
Okay.
So, yeah, good call with that. So that's all we've got for 7.5. Now we'll bring up 7.6 just in the last couple of minutes of class. But it goes into buying a home. And there's a lot of setup, a lot of extra stuff. So this is one reason I'm mentioning it is it will make things go a lot smoother. You read up on this, and really, I mean, you only really have to read these couple slides, which are already up on e-learning under resources. It will very much quicken how it goes, because if I have to go through and read it off to everyone and explain all of it, it will take a lot more time. So just for next time, find some time over the weekend to read through these 1, 2, 3 slides. So I guess you could call that your homework. But yeah, so that's all I've got. And we're about to get kicked out. So anybody got any last second questions?
Help me work
No.
through this and figure out exactly what's on my heart.
Oh, there she is. You finished?
Oh yeah.
Okie dokie. Well, this will be up on.
Feel something deeply when they hear me deliver the speech. Everybody walk around together. Let's
We
go.
will
Love you.
see you guys
Love you.
next time.
You got this.
Adios.